So we'll see the next type. Design DFA to check whether the given string contains 100 or summation equal to 0, comma 1, where summation is equal to 0, comma 1. So this is the question. So this is the second type in which we are dealing with contains. So it may be given in the problem that certain substring is contained in a particular string. Then you should accept that. So here the logic part will be starting. So first is the logic part. The input given is 0, comma 1. Then we will see the set of states Q. So we'll wait for some time. Q0 will be the start state. So we are going to start with Q0. Finite set of final states. So that we'll be seeing after some time. So in the implementation part, as we had seen in the last problem also, we will require the transition function. Using the transition function, it will help us in drawing the transition diagram, correct transition diagram. So what is the transition function for DFA? It is Q given by delta Q into summation gives us capital Q. So we'll have Q set of states into summation. Input is 0 and 1. Q0 state which is the start state representing 0. Then we have Q1 representing 1. Now based on the substring that we want, we have to choose. So 1, 0 is a substring. So any substring that is given, we take part by part. So we had 1 which was already covered. Next is 1, 0. So Q2 represents 1, 0. Q3 represents 1, 0, 0. So we choose 1, 1, 0 and 1, 0, 0. Now we start with Q0. Input is 0. So we get the string 0, 0. So there is no state representing 0, 0. We ignore the left input. Single 0, yes, there is a state. So we write Q0 when we get 0 as the input. Then again we are in state Q0, we get 1 as the input, 0, 1. We ignore the left 0. Then we will write here Q1 because 1 is represented by Q1 state. Now we are having in Q1 we already have 1. Then we get 0 as the input. So it becomes 1, 0 combination which is given by a state called as Q2. So Q2 represents 1, 0. Now 1 is already present. There is 1 coming in. So we get 1, 1. So there is no state representing 1, 1. So we ignore the left 1. Single 1. Yes, there is a state representing single 1 which is Q1. Now we are in Q2. Already we have got 1, 0. Another 0 comes in as the input. So we get Q3. 1, 0, 0 which is Q3. Then 1, 0, 1. 1, 0 is already present. Then we get 1 as the input. So 1, 0, 1. There is no state representing 1, 0, 1. We ignore left 1. 0, 1. Is there any state for 0, 1? No. Is there any state for 1? Yes, there is a state for 1 which is Q1. So we go to Q1. Now Q3 is the final state because we want contains. The string 100 should be contained in the particular string. This substring should be present in the string. So once we get Q3, that is 100, suppose we get 0. So 100, another 0 comes in. So there is in contains, what logic we are supposed to use is, this contains can be present anywhere in the beginning or in the end or in the middle. But once this 100 comes in, means it will be there. So we stay in the same state Q3 even if we get 0 or 1 as the input. So this is called as a trap state. So once we get into the state, we cannot come out of this state. That's why it is called as a trap state. Now, why do we require this? Because, as I said, contains can be anywhere. It can be in the beginning or in the middle or in the end. So for all the cases, you need to accept the string because once the substring 100 is present, you need to accept. That's why 100 is present. And whenever any 0 or 1 comes in, we will be accepting it. If nothing comes after that, no problem. Then we'll draw the transition diagram based on the transition function. And then we will check this with an example. So first is the state Q0, which is the start state. Then we have Q1. Then we have Q2. And then we have Q3. Q3 is the final state. We encircle it twice. Start state represented by an arrow. Q0 on getting 1 will go row wise. So Q0 here on getting 1, on getting 0, we go to Q0. On getting 1, we go to Q1. So both the inputs we consider. And based on that, we draw the transition Q0 to Q0 on getting 0. Q0 to Q1 on getting 1. Then next row Q1 to Q2 on getting 0. Then Q1 to Q1 on getting 1. Then we go to Q2 state. Q2 on getting 0, we go to Q3. And Q2 on getting 1, we go to Q1. So 1, we go to Q1. Then Q3 on getting 0 or 1 as the input, we stay in the same state. Now we'll see an example through which it will be more clear. In this case, it is contains. So we start with Q0. Contains means it can be anywhere 1, 0, 0, 1. We'll take this as example. So it contains 1, 0, 0. So we should be in the final state when we go through the entire input. So Q0 on getting 1, if you check the transition diagram, we go to Q1. We move to the right, 0, 0, 1. Q1 on getting 0, we move to Q2. 0, 1. Q2 on getting 0, we move to Q3. Q3 on getting 1, we stay in the same state Q3. So we have checked the entire input and we are staying in the same state Q3, which is the final state. So this can also be represented in the form of the model, the finite automata model. If you remember, we have the input 1, 0, 0, 1. These are the inputs. We have the read head. Then we have the finite state control. It will read from left to right. So on getting, we are in Q0 first. On getting 1, we go to the next state, that is Q2. And then we move to the right. So we'll go to Q2. Then in the state Q2, when we get 0 as the input, we move to Q3. So, and we move to the right. So we are in Q3. And Q3, when we get 1 as the input, we move again to the right and stay in the same state Q3. So we are in the same state Q3. Q3 is the final state, which is the accepting state. And thus we are able to solve this problem of contains. That is, we have designed a DFA which will accept the strings containing or contains 100 where input is 0, 1. So we started with the logic, the set of states, which all set of states are there. So once we are done with the transition table, we can write here the set of states, that is Q0, Q1, Q2, and Q3. These are all set of states. Final state is only one in this case, which is Q3. So accordingly, we need to mention. So logic part, then we started with the implementation, that is the transition function and the transition diagram. And then this example is for checking whether the logic is correct or not. Logic and implementation is correct or not.